Thank you everyone for coming. And let's start. First off, some introduction. You know my name. I'm a bit of a nomad, and what you see in the bottom is gibberish. If you don't understand it, it's fine because you don't know Finnish then. But that's my song, which means it says it's not my home, which is a good song for a nomad like me. I work for Red Hat. And work on FOSS. I've been working on free software and open source for a long time now. And I'm into flying, and I love cats. So I had a similar talk at RustFest, so if some of you were there, then it's a recap. Otherwise, it's a background story, real quick. So the whole thing started with this project called GeoClue. It's a daemon, it's a service on your Linux laptops, which finds where you are through different sources and stuff. And I've been, it's a geolocation service. It's, as I said, it finds you where you are, and it's written in C currently. And I've been a maintainer since the rewrite. It was in 2013, I think. I thought, like, let's oxidize it, but you'll ask why. And I have reasons. And it's called crash reports. I got a lot of crash reports, and Will was telling me that on their end, in Endless, they saw a huge amount of crashes in GeoClue. So I was like, yeah, I'm working on that. So permanently. And it's my spare time thing, so I don't want to, you know, chase after crash reports and C code. So also, like, location is the most sensitive data that is about you, so you don't want to be trusted by everyone and anything, and especially if it's written in a unsecure, very unsecure language, it's not a good idea. And I just love Rust for various reasons. I have a blog post about it if you want to read. So I thought, like, let's do it, let's oxidize it. But what were the challenges that I was looking forward to? First one was Mason. It's a build system that is being used by a lot of projects out there now. I thought, because Mason doesn't have, like, built-in support for cargo, so I thought, like, it will be a bit of a challenge. The other thing was zbus. Like, as I said, it's a service on your laptop, so it's a zbus service. I'll talk about zbus a bit. If you're not familiar with it, it's a very efficient binary interprocess communication protocol, and it's used in desktop and embedded systems quite a lot. There is one crate already existing. It's called zbus RS, I wasn't very happy with the API and stuff, but I wanted to use it, even though it depends on a C library called libdbus. That library is not very famous for its interfaces and stuff, and I think there's some bunch of other problems with it. I don't think not many people use it anymore, even. And so yeah, we had this many issues, but I still decided to use this crate because that was the only one, and I didn't have a lot of time. It's as I said, it's all my spare time stuff. I even contributed to it in the beginning, a few patches there and stuff, and then we had a Hackfest. We do this Rust GNOME Hackfest, which is about GNOME and Rust, and about every 6 months, twice a year. And the one in last year, one of them was in May in Berlin, and I started working on this to oxidize GeoClue. But turns out, like, the Mason stuff turns out to be very much easier to work around. Like, the workaround was pretty simple, and it was not a big issue. So I could call from Mason. I could call cargo, and cargo does its own thing, and that's it. So I didn't need something back from the results of cargo into Mason. So it simplified a lot of things. But the zbus RS API turned out to be quite overcomplicated, and I couldn't figure it out. I asked others around, and they couldn't figure it out either. So I was like, how about I write first zbus from scratch? And yeah, I thought, how hard can it be, right? Let's check it out. So I started looking into what's involved, and on a high level, it's you have objects, and each object has a path. It's called object path, and it's just a string that represents that object on the bus. In dbus, you have buses, like it's a think of it as sockets, and they're talking to apps talking to each other on those sockets, and the services expose objects, and on those objects you have certain interfaces. Each object can support multiple interfaces or one interface, but it has to support one at least. And those interfaces and then methods on them. So it's a bit dynamic. Like the reason it's like we have interfaces and not methods, an API directly on the object, is that it could be more dynamic, that you can on the fly change, like, okay, this object now supports this interface and not. So yeah, you have methods on them, simple input output parameters, and signal is just the same, it's just the other way around. So you have parameters from them, and you get signals called on you, like as a client you get signals and you send method calls. And also you have properties that represent different properties on your interfaces. But on the low level, it's just message passing on the sockets, as I said. And there is a wire format for these for interfacing with the dbus. And it's also, you can call it G-variant, but not quite, because G-variant is a glib API to handle this wire format. But the people who were working on that, they made some changes, and the intention was to put those changes back into dbus spec, so dbus itself will change, but that didn't happen for some reason. I don't know why. So yeah, G-variant is slightly different than the wire format of dbus, but it's based heavily on that, so there's a lot of similarity. So at least you can have the same API. So for example, glib has dbus APIs, and they use G-variant. So you deal with G-variant, and they convert behind the scene. And this format G-variant is used standalone as well. Projects like OS3 and Flatpak and dconf, they're using it. There are some examples, but I think there's a lot more out there. And so what is this wire format? It's just they defined a bunch of data types and their encodings and since it's a binary format, there's the alignment consideration in the memory. So, but it follows natural alignment. So if you have unsigned integer of 4 bytes, so the alignment for that is 4 bytes. If it's 8 bytes, then it's 8 bytes and stuff like that. We'll see that later. And each data type has a signature. Signature is just a string that represents that type. So the basic types, they have one character string, like for example S for strings and stuff like that. But for complicated one, you have like longer signatures. But there's limited to 255 characters because we will see later why. And basic types are like mapping very nicely to the Rust basic types, so that's not hard. And containers kind of also, like you have arrays, which is like vector or an array in Rust, structure, and dictionary is just like hash map. And we have another type called variant, which is it looks very simple, but it makes things a bit hard because dbus, the wire format is not self-defined. So you have to have the signature. You need to know the signature or what data is in there, what kind of data to be able to decode it. So it's not self-describing. But this type is, because for the signature for this type is dynamic. So you get it in the encoded data, what is actually in the variant. So you can put it any of those types that I mentioned in the variant, and you put a signature in before it, and you send it to the other side. So it's for dynamically typing things. Used quite a lot actually on dbus. Example, so that you understand what the hell am I talking about. So let's say you have a string you want to transfer in this format. So the format, like we will go from right to left. Oh, and the bottom you have the byte addresses in the message. And I've highlighted the 4-byte boundary, so you can tell more easily what's what. So yeah, the string it's supposed to be null terminated, and just before the string you put the byte length. It's not the it's the length of the string, but without the null byte. That's I learned it the hard way. I forgot about that, and test cases weren't passing, and then I found out. So yeah, you have the length, and then since the length is the fixed part of this string encoding, and that's 4 bytes, you have the alignment of 4 bytes. So that's why we needed 2 bytes before it, null bytes or padding, to align it on a 4-byte boundary. And invariant, it's the same. There's a reason I'm giving you these details. You'll see later. When you put a string in a variant, it's the same as you look at from right to left. You have the null byte, you have the string, and you have the byte length of it. And again, you need to pad it. And since you are putting it in a variant, what you do is the first part is the signature of the data, because you only know at runtime, if you see decoded data, you only know at runtime what is encoded in the variant. So you need a signature first in it. And signature is encoded in the same way as a string. The only difference is that the length is 1 byte size. So that is a good thing, because then you don't need any alignment, because it's 1 byte. But you're limited to 255 characters of signature, but that's more than enough. You don't want a complex type so complex that it's more than 255 characters long. Anyway, so that's how you encode a string in a variant. So I was like looking at that, I was like, that's not so hard, let's do it. So I was working in the Hackfest and after for 3 days, well, I was not distracted by this work thing, so it went very fast. And I managed to make some good progress in just a few days, like established a connection, called a method on the other side, and I was like, yeah, I can do it, let's do it. Cool. So I decided to create a new library called zbus, and why name zbus? Because it sounds really awesome, so I chose this name. But I thought, like, let's start with the hard part, the lower level. So if I'm writing a dbus library, I should write it completely in Rust, like from scratch. And I call that part zvariant because it deals with the variants. It's called because gvariant and all, you know. So I had these goals in mind, like how I would do things, and I wanted it to be very efficient. If possible, even more efficient than the C implementation in glib, which I think I'll achieve, if I haven't already. But the silly goal was I wanted to be efficient from day one, and I don't think that's a good idea. So if you ever start a project, don't do it this way. I came up with this first trait. I was like, yeah, this is the trait that will all the data type that can be encoded and decoded from this format, they will implement this interface. And as you can see, there's lifetimes in there, and that's because I wanted to be super efficient. So lots of issues, of course, with any project, if you start from scratch especially. Loads of fun with lifetimes. The variant representation proved to be a bit challenging. Like the most natural I was thinking first was like, I can have generic type on the variant value, like have a struct signature and then value, and that's it, and that would be generic. But then when you are decoding, you need to know, how do you decode? Like you need to know the type in advance, like the whole type. So it wouldn't exactly work. So I went with enums. It's much better, I think, with that way. But eventually I dealt with all these problems, and I had test cases for each data type I added support for, and it started to look really good. And I was like about to, I said, let's just document it and just, release the first version of zvariant. It would be cool. But as soon as I added the support for hash maps, like the dictionary type, test cases are not passing. I thought it's a test case, but it wasn't. I'll give you a chance. If you can tell me what is wrong with this. This is where it goes wrong. Like when I added, like when I put it in a variant, the dictionary, so I hit a problem. So I was looking at this, and it looked right. This is just the same as we did string in a variant. Now it's an array of 64-bit integer in an array in a variant. So how you do it is the same, very similar to the string. You have the array itself, and you have the elements. Like the first element need to be at least padded, and you have the length of the array in bytes. By the way, this is in bytes, not the number of elements in the array. And then the padding for the length itself, and then the signature, like we had with the string. But this time you have like A is for array and T is for the 64-bit integers. So you can tell what it is inside the variant. But there is one thing that's wrong in here. Can anyone tell me what is wrong here? Huh? No. What about alignment?
Like you're not calculating the alignment correctly for the variable size array?
No. Okay, I'll move forward. So I couldn't figure this out for many days, right? So, and I was like back to dbus spec reading and staring and stuff and figuring out what the hell is going on. Till I realized that I think I'm wrong about the padding. As I said, like the variant does not require any padding itself because it starts with a signature, and signature's length is 1 byte, so that doesn't require any padding. But the more I read the spec, I was getting more and more sure that the array itself, or the anything in the variant itself, the value of the variant does not require padding either, and that's what is wrong. So I was like, okay, how do I fix this? I was like, this needs a complete overhaul of the whole how the variant encoding and decoding is working. So, like, okay, whatever, I have to do this. But I first was like, okay, this lifetimes, like each time I made any change, significant change in the whole thing, lifetime would come on the way. So I was like, this is not good, and that's why I shouldn't have started with super efficient implementation from day one. So I was like, let's kill all the lifetimes first. So the way I did it was I created this data type. I looked around at first, like if there is exactly like something like this. There is cursor, but cursor is not exactly like this. So this allows you to create like a shared. You can have a slice of a data, and you can have as many slices as possible and pass it around the clones of it because it uses a RC, and it knows its position in the whole buffer because the alignment is based on your position in the entire buffer, the entire messages. If it's a dbus message, then the entire dbus message. So you need to know where exactly you are at that point. And efficiency is not a religion, so we can do it later. It would be nice, of course, but. So after 2 months of this lifetime killing and creating this new interface and everything, I was done. And I was like, okay, let's see the test case. And I was sitting and I was about to hit enter after cargo test, and I was like, would it pass? Would it pass? No, it didn't pass. So I went back to more spec reading and byte staring. Turns out it wasn't the padding after all. You do need to pad everything, and it was the length. The length does not include the first element's padding. The specs wrote it very clearly. For some reason, I missed that. So yeah, that's the only small thing I had missed previously, and I did the whole changes and everything, and it was this trivial thing, and I fixed it soon. So it should be 16 because yeah, yes. So there's 8 bytes and then 8 bytes, so that's 16. Yeah, trivial to fix. Well, Christmas holiday well spent. I published the variant. It's out there. You can find it. I've added docs too. You can use it in in a very easy way. You can you have in this example, for example, you have a string you want to encode. You tell it which format. Currently, we only do dbus format, so it doesn't matter. And then you can decode it back. Simple. A bit slightly more complicated integer in a variant, for example. Same thing, but you convert it to a variant and then encode the variant itself and then back to a variant, and then you can get the value from the variant. So don't use it yet, but because I do want efficiency. So I'm back into that, and I think I'll need API breakage for sure. Not just because of that, but also imagine what first issue anyone filed on this crate. Support for Serde. Like, why don't you have Serde API? So I was looking into that, and I was like, yeah, it makes sense, and if I can make it work, and I'm working on that. I have an experimental branch for it. The main challenge with Serde is that it's way too generic. So I'll show you. So I have a proof of concept serializer implementation already, and it works as far as I know. But if you're familiar with Serde, usually you get like an API like this, where you say 2 bytes or whatever, to write, or whatever is the output of the output type of the API. And but the only difference is that I'm requiring another trait from the type you want to encode or later decode as well. And the reason is that I need the signature at the moment, at least. So I'm trying my best to, because otherwise what's the point of Serde? Because with Serde, you should be able, anything that implements the Serde serialize or deserialize, that type should be serializable by all the crates that implement Serde. And that's the whole point of it, is generic. So I don't see much point of providing Serde if I can't remove this limitation. So I'm working on it. Even if I provide a macro, right? Like Serde provides easy derive macros, so you can put it on your custom type, and that has serialize and deserialize then. So you can add one more, but just for my crate you would add that. That's weird. So yeah, I'm really trying hard to avoid that. Yeah, drop it. And once I have that done, I'll look into deserializer. I looked a bit, but I haven't done any implementation. And I think the byte order should be configurable. Right now I just assume native byte order. It works fine with dbus because it's on the same machine. And G variant support shouldn't be that hard, but fingers crossed. And a few goodies like that, right? In J variant, Z variant, I mean. And also large array handling. I've been told, like some of the projects, at least OS3 for example, store like a large array in a file, which is variant. It's in a G variant format, but it's a large array, and it's not ideal to have to load it all to decode it. It's not ideal at all. So I would like to have some kind of streaming API that you can read easily. Like you say, I want to read from index this to this, and that's the elements you get from the array directly from file. So yeah, back to dbus, what I want to have. So I already have some implementation. I haven't released zbus yet at all because Z variant is not finalized yet. But this is how it currently looks like, and it would look something like similar on the low level at least. So you have you establish a connection. You tell it which service, then which objects you want to talk to, and you tell it the interface and then the method and stuff. and that's how you call a method. And then you get a reply, and then it's based on the variant API that I just showed. So yeah, this is the standard interface that any dbus broker on your machine will implement, so you can use it. In terms of dbus, after I have all that, I need to do a few things like receiving messages maybe. Yeah, and signals. This is not just methods. Async. Hopefully it will be async, just async STD based, because it's the coolest API I see for async in Rust. A high level API then, like once I have the low level, so that you can work with objects. I want to model it after glib's API, where you, if you are a client, you create a proxy object for a specific object on a specific interface, and then you can call different methods or get read properties from it, and it even caches the properties local, like on your side. In terms of server, you have something similar. You have a server object, and you add an interface to it, and then you implement those methods like anything, like any trait. So it will be trait based on the server side. Code generation. A lot of projects out there, they use, especially client side, they use code generation because nobody has time to write individual interfaces yeah, so it's harder if you don't use code generation. And in glib, there's the gdbus code gen, which is really cool. And I think Qt has something similar. I never managed to use it, but it's there. Maybe also macros. That would be cool. Some people ask for it, so that it's. I worked previously on a language called Vala, and it has like special syntax for doing dbus server and client-side implementation, which makes it really convenient. So macros would allow for something similar. And a lot of other easy stuff. That's it. Sorry. I'm done early.
So we have time for questions.
Is the Z in zbus position?
I'm not answering that. The question was if zbus stands for Zishan. First of all, it's zbus, not zbus. That gives you a hint, right?
Did not fully understand what the great differences with the current
So there are two. So the question is, what's the big difference between this and the current dbus RS crate, right? The first one is that it doesn't depend on the C library, the libdbus, which is not just that it's in C, but it's also the API is not that nice, and it shows in the Rust API, that the wrapper API. So it would be good to break away from that for multiple reasons. And yeah, so the whole reason I started with the whole effort was I want something very safe. So, and if you depend on a C library for your main thing, it won't be very safe. So
Question time or?
yes, yeah.
The first one is like you mentioned OS3 and large arrays, and I think that what they usually do is kind of like an idiom in OS3 is they memory map like this large variant stuff
Yeah.
into map memory, and then just the code out of that, and the byte, like this large blob, they're basically just like pointers.
Yeah.
I think that in our case, like it makes sense to have like slice references to this memory map area if you can.
Yeah.
When you're on this, that's a comment. Then the question which is, do you know like how different the variant stuff is between?
Can I first repeat for the recording or streaming? What was that? For the array, no, there was this. Lucas said that there's usually for example, in OS tree where you have the large arrays, they just use memory mapping they map the whole file, and then they can read whatever part they want to read, and that's the way.
The question instead was like, do you know how much difference there is between the variant in dbus and the variant in Q variant? types, like what it is?
The variant part is the same as far as I know. It's the arrays and it's the other data types that are encoded a bit differently.
Is it like majorly different, or
There is some. It's not majorly different. I'm pretty confident that the API I have, it will not need to change. So it should be good.
So I have a small piece of code that I need to write at some point just to retrieve a couple of numbers from Modem Manager over dbus, and I was going to do it in Rust because why not? And I just wondered if you had any sort of rough feel for when this would be the right crate to pick versus the existing one.
So
Roughly.
yeah, the question is if I can provide a rough estimate on when zbus will be ready for consumption.
Basic functionality.
Yeah, basic functionality. Depends on what basic means. But I would say ideally I think I should be done by summer, but you need to keep in mind it's my spare time thing, so it depends on a lot of things, and I have a life too, so it comes in.
Is all the code sort of in that repository, is that everything goes in there straight away, or is this?
Yes, yeah. I even my experimental branch is in there.
Okay.
So, but on the dbus side, like when I change the zvariant API, it wouldn't be such a big change. So, if you want to accelerate things, please do contribute if you can, and we can collaborate. There was already one person after RustFest, they contributed some patch, and it was nice, and yeah, so it's already possible. And I will handle, once the zvariant API changes and you have to port it, I'll do the porting, so don't worry about that.
Okay, so you don't expect the zbus API to change so much?
Yeah, I only expect it to grow. Like it's the existing API won't change much, as I don't think so.
Okay, cool, thanks.
Any other question? Now, as you have done a larger Rust project and had some problems finding errors, I would like to ask you if you have some tips on debugging Rust programs, because what I'm currently doing is including a ton of print lines and then removing them again when the release is running out, and that's sort of primitive.
I did that too, to be honest. Yeah, one of the things, like if you go to the channels, the Discord channel and IRC channel, there's a lot of really helpful people there. So I paste codes in somewhere in the playground, Rust playground, and I ask, and usually there is an answer. So that, for me, that helps a lot. And the only thing is that you need to create like a small test case for your issue that doesn't involve all the details that that are specific to your project. So if you can create a sample code, it really helps a lot to get help on your issue specific.
I just want to add to this comment. You can use the dbg macro, and it returns the contained value. So no need for extra print line statements. Just put dbg around parameters or return values or whichever, and it will work.
You mean the derived debug?
No, the dbg debug macro.
Ah, okay. So
It returns the contained value.
okay.
So now you repeat it.
Sorry.
Did you want to repeat that first?
So the question, well, it was more like a suggestion how to make debugging easier, and there's this dbg macro that helps with, you know.
It returns the contents. You can
Yeah.
just edit.
Yeah.
So I did have a question as well.
Uh-huh.
You started out saying that you wanted to make things go really fast by using lifetimes to make sure that data structures are in one place and prevent copying, and then you found it very difficult to maintain, so you ripped it all out. There seems to be a common progression it seems amongst developers. Are there any other experiences that you had that you began trying to use all the Rust features and then you pulled them out? I think the speaker before said we were going to use generics all the time, and then he said, oh, that wasn't a good idea. Do you have any other suggestions that you could think of off top of your head that
No, that first I would like to clarify, like your question. Do you have to repeat, right?
just if you had any more tips?
Yeah, the question is if I have tips about, like, as I said, like I removed the lifetimes, and then it was easier to change things. If I have any suggestion of any other similar examples, right? That's what the question is. First of all, I would clarify that I removed lifetime temporarily. I want to, first change it because I was doing a lot of changes, so that was on the way. So once I have done that, then I can put it back. So it's not like I've removed it permanently. So, but apart from that, I don't think there's any other things that I had to remove to make things easier. But certainly, I would comment that a lot of times Rust developers tell you like, yeah, don't mess with lifetimes, and you don't need to know about lifetimes. I don't think that's true. You need to know about lifetimes if you want to do really good Rust, code. If you want to code it better.
So on the, I guess in the GeoClue server case, you're expecting the Rust version to be pure Rust and not be a GLib-based application. On the client side, I'd expect that you'll end up using the GeoClue client in GTK-based applications, for example, which will already have their own DBus connection via GDBus.
Yeah.
Do you anticipate any problems from these sort of two-headed applications?
The question is, since I will only oxidize the server side of GeoClue and not the client side, which is a library, which is glib based, and it's very good for glib applications out there. And also, it's good for other languages too because of the geo-object inspection and stuff. Yeah, if there would be any problems having these two different worlds in the same repository. No, I don't think there will be any problems. And the good thing is that the GeoClue service is quite standalone. The code is pretty standalone. So no, I don't expect any problems.
I actually meant more in applications which, some random application which wants to talk DBus and they live in Rust and use GDK. Would you anticipate that they would continue to use
I get it now.
DBus, or would they use zbus,
Uh-huh.
also use a bit of GDK to make their own connection?
Yeah. So the question is if the recommended method for the apps that are written in Rust, would it be to use this mycrate, the Rust crate to talk dbus, or to still use the glib-based C API I provide? No, I think it's up to them. But if I get to the code generation and macros, then it would be super easy to create the interface needed to talk to GeoClue. So then they can just use that. And I think that's what they should use, ideally. Yes?
So I had a experience working with the dbus version of the Rust and dbus. And I found one of the things that I struggled a lot with was to actually decode the signature of the message that I got back from the other end. So I don't know if it's possible to for variants at least, and maybe to make a default macro that could print out whatever you know about the message, so that I can see why I'm not getting the results I want. That would help me a lot if that's possible. I don't know.
I'm not sure if I understood the question. Like, you want the zvariant to be able to tell you about the data that is contained. If it is, if it's a variant type, then yeah, of course you have the signature encoded in the data. But if it's not a variant type, then you don't have the signature at all. So you can't do that. But if you know the interface, you know which signature it would be, then yeah, you can. No? I don't think so.
Thank you very much. Not 3, 2, 1. Okay.
Thank you.